So here we have a simulated business application, which shows two different kind of lists of employees. One which belongs to the Department of Sales and one that belongs to the R&D department. Now, if I click in here, I write something, I hit enter, you can already see that the application is quite laggy. So we will get here a name that entered. I can jump over here, do the same, but you see that there is a huge delay on what I typed and actually when it gets rendered. Now we want to optimize that kind of application. So let's see how it is actually structured. Let me make this a bit smaller again. So what we have seen here are these two adjacent lists. These are both coming from the app employee list. They're just getting feed with different kind of data. Now if we go inside here, we see that we have here our app employee list, which renders the data that comes in via here that input. And then for each item in the row, it calculates here that number based on the input it gets. So we see here that calculate function. That calculate function resides here in our component, which makes here a so-called simulated business procedure, business calculation, which is quite costly in this case. It calculates the Fibonacci number. Now, one thing we can optimize in Angular applications often is the change detection cycles Angular has to perform. Generally speaking, it is actually quite fast, but in certain cases, we can actually give it some help. So let's take a look at our component tree. So what we have here is that app root, which is the very top, and then we have that employee list, which is the one from sales, and the employee list from R&D. And here our app root in between. So this is kind of a tree structure. Both of these employee lists below have different kind of rows below, right? So we have here the employee list for sales as well as the employee list for R&D. Now, whenever we insert something here in our employee list for the sales part, what happens is that at the very top here, the change detection cycle kicks in because it has detected some changes, and it will go down on both on the employee list as well as on the employee list for R&D and recompute every row, which means recompute Fibonacci for every entry here in those lists, in both of them. Now, already in this case, we could optimize by telling Angular, look, we just changed here something on that side, so you can actually avoid doing the change detection for the whole part of the employee list in the R&D section. So let's close this and see how we can do that. In our app employee list, we can actually go down in our component definition, and there's a property called change detection, which you can set to the change detection strategy.onPush. OnPush will actually now trigger change detection only if the reference of the data passed here via the inputs has actually changed. So we got a new list of data. Now this obviously happens here for the sales department once we type in here a new person, but it doesn't happen for the R&D part. Let's see whether our performance increased here. Let's type in here. You see the animation is already faster. And we actually get already a better performance. But there's still some lag in the application. Let's see how we can further improve it. Now another point we can improve is this calculate here. This happens for every entry in the list every time we change that list, right? This is something we can actually avoid because we know if you go to that calculate function that whenever we call Fibonacci with a certain number, with the same number, we will always get the same result. So we actually can avoid doing the recomputations every time. That's because Fibonacci is a pure function. Now what we can do is actually to use Angular's pure pipes to help us improve here the performance. So let's generate here a new Angular pipe. And we do that with the ng command, with the generate operation. We call it pipe and we place it into the employee list and we call it calculate. For now we skip the tests and this creates a new calculate pipe here and it also inserts it properly in the employee list module. So let's go and have a look here at our pipe implementation. Now let's refactor our employee list and move over that logic. First of all, we can move over that Fibonacci calculation, which will happen here. So we get here a number, which is a number we pass ahead to the Fibonacci calculation. And here we just return the result of that Fibonacci. Now, obviously, we also need to move over the Fibonacci function, which we can just here cut out. And let's also here remove that function, which is no more needed. Let's move that over to the very top here. And so here our pipe is actually done. Now, Angular pipes are pure by default. We can change that via that setting here, which is called pure, and set it to false in case we have a non-pure pipe. Meaning pure means that whenever the same input comes inside here, that value is not calculated anymore because Angular knows it has seen it already before and just returns the result. So let's save this for now. we can now go over to our employee list, which we need to refactor because that calculate function doesn't exist anymore. So we can remove here this, and we can now use our new calculate pipe. Now let's save again. Let's here make our window a little bit bigger. Now let's type in. You can see how fast the typing now works, right? I can type in new values and it's really speedingly fast. So we have actually taken two measures. First of all, the change detection, which we changed to on push, and then we introduced a pure pipe to optimize our computation, which happens inside our lists.